Hello, this is Mr. Ferreira, and I'll be talking you through the sign test. Now, this is the first inferential test that we do. It's also meant to be the simplest, and it's the only one that you actually do need to be able to calculate the value for the test. It's called a sign test because we use pluses and minuses as our signs, and we see that it's a test of significance for paired or related design. So we have repeated measures is the key to this, or a matched pair design that we use. And it will be fairly straightforward in terms of an exam because what we find is that they can't ask us to do too much in terms of a calculated value, so it will be fairly straightforward. Now, these are the aspects of the sign test that you perhaps need to memorize. So they could ask you kind of when would you use the sign test? And so one of the reasons is, of course, if we're looking for a difference rather than an association. Repeated measures, I've said before. And then it says here that the data is organized into categories, and this is called nominal data. Now, we've spoken through different levels of measurement, and we use the sign test when we have a situation where we've organized the data into nominal data. So data doesn't necessarily have to be collected being nominal. So for example, I could look at how many words people remembered and have a score for their words, but then it is organized into nominal data because with repeated measures that either have an improvement, and we can say, well, that's a plus, or it could be not improve, so therefore it's a minus. So pluses and minuses are nominal data because you can only be in one or the other. And we do also have equal signs, and you'll see this is a special case where if we do have equals, we have to disregard that particular participant because when we're testing for a difference, or certainly within repeated measures, if there isn't a difference, we can't then do some kind of comparison with somebody who doesn't have a difference. Now, the next slide is a bit of taking us through kind of the processes of what we do with inferential statistics. Now, what you'll find is that every single test follows the same type of process, except for each test has its own unique way of doing things. We don't do inferential tests unless we're actually testing a hypothesis. So we've got to have some form of hypothesis. The reason for this is we need to know whether the hypothesis is one-tailed or two-tailed, or directional or non-directional. Then you'll find that all the other tests, there will be some method of them calculating the value for that test. But for this one here, if they don't already give us the pluses or minuses, we need to indicate whether something is improved or not and put the pluses and minus down there. And we call this a calculated value. We then also need to go to a table of data, which will be the critical value, and we need to do a comparison between the two. And once we've done the comparison, we see that we've decided on significance or not. Now, of course, a lot of this looks theoretical at this stage until we actually look at a question, but I want to go through these slides first, and then I'm going to open up a question, and we're going to have a look at that. This is an understanding of step 2. We see we have student 1, 2, 3, 4, 5 going down from that, and we can see better or worse, better being a plus, worse being a minus. Now, it doesn't really matter whether it's a plus or minus in this particular case. So, for example, if I'm give you a test of anxiety, and I then do some kind of treatment value, and then your anxiety drops, then we can say that's better. So that's plus. Or we can see how it's all relative to each other, the plus or the minus. The critical value is important to us. When I was talking about significance, I spoke about how we compare numbers. Now, the numbers that we collect from our experiment are the calculated numbers because I've actually done something to collect them. However, there's a mathematical equivalent set of numbers, and these are the critical numbers. And so that's why we do a comparison between calculated and critical. Now the critical values will always come in a table. Now sadly, not all those tables will be bright orange and purple. Most of them are black and white. And the great thing about the table is it gives us everything we need to know. So for example, in this table, we see level of significance for one-tailed. So if I do a one-tailed test, I'm going to be looking at these values here. Now almost always we choose 5%. Now of course, if it was a two-tailed test, this is why the hypothesis becomes important. Then of course I'll be looking at that 5% over there. And down the column here, we have the number of participants. So it says you need to know the level of significance in order to get your critical value. As I said, most of the time we use 5%. So of course, in an exam, they may ask us to look at something else. So of course, we see here we have 1% on both of those. So they could ask us to have a look at 1%. And I have actually seen a question where they've asked us about errors where something is significant at both 5% and 1%. The number of participants is also required for this particular test, and also whether it's one or two-tailed by looking at the hypothesis. So what it does mean that each of these numbers are unique to a particular experiment. So let's say I have 15 participants, and then you'll see that all the values I'll be looking at will be at the bottom. Now it could actually be that 3 of those people don't have a test of difference. So therefore, I'll have 12. So then I'm looking at this set of numbers. And you can actually see how the critical values will change. So if I get the number of participants wrong, I may, for example, think that the critical value is 3 rather than 2, and that could make a big difference in the overall score. So I'm going to now switch to a practical example. This is an example that you did in the summer. Now this video is mostly for those people who perhaps are struggling with the sign test and hoping that it will help them kind of understand the whole process. So here we have a question talking about effective treatment for depression. We also see that we're looking at a number of absences for each of those patients. Now in this particular case, of course, what they measured was the days of absence. And of course, somebody might have 20 days of absence. So therefore, they're improved if they have 18 days of absence over a period of time. Or if they're deteriorated, mean that they've had more days of absence. So obviously in an exam, it would be really quite nice to see if they gave us a table like this, because they've already filled in the pluses and minuses. Now that does seem unlikely, but of course this is an example question. So therefore we need to consider a table like this, or a table that just has the number of days of absences. So there's nothing too frightening about this particular table. We see that altogether there are 20 patients. But we also see the patient number 2, number 9, and number 20 didn't have an improvement or deterioration. So for this one, I'd say that our number of differences that we're looking at is going to be 17. Another way you can do this is if you count how many pluses I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pluses. And I have how many minuses? 1, 2, 3, 4, 5. So if I add 12 and 5, I get 17. So n could be the amount of minuses and the amount of pluses added together will give us a value of n. So looking at this, it asks us a couple of questions. So it first says, explain 2 factors that the researcher had to take into account when deciding to use the sign test. Okay, so going back to my file, these are the factors up here. We've got to look at repeated measures design, nominal data, or looking for a difference. So we then can read the question and we see that it is repeated measures. because it says from the employment records, the researcher kept a record of the number of absences from work each patient had in the year following the treatment. So they got the before and they got the after. So it's repeated measures. And it also says those patients who had fewer absences in the year were classified as improved, plus, or deteriorated, minus. So that's categorical data. Now you see that we can say from this study, so the key to this question, because it's worth 4 marks here, is for us to actually show the examiner we understand what we're talking about. Okay, so I've got test of difference, repeated measures, nominal data. So I've got to actually refer to the particular scenario that we have here. Now, of course, it is a test of difference. It's a test of difference between the levels of absences before the treatment and the levels of absences after the treatment. That's also a reference to repeated measures and the nominal data. So the mark scheme actually says that. So I'm going to avoid the first bullet point that says nominal data and go to the second bullet point. It says testing for difference in the number of absences in the year following and prior to the treatment. So that explains it quite clearly. It tests the difference. We also then have the repeated measures as the same patient's work records are compared. Now, of course, I had forgotten about that for a while to make a reference to that. But of course, it is, whenever we do repeated measures, we are actually referring to the same patients. So for 4 marks, explain 2 factors, and one of the factors would clearly be your test of difference, and the second factor would quite clearly be that it's repeated measures. Now, the reason I'm not concentrating on the nominal data here is that I actually think it's the hardest one to explain. If you look at kind of the wording there, it is quite important for us to kind of see that you have to explain how improved or deteriorated or even neither ends up being a plus, minus, or equals, and that's categorical data. So actually, it's a really good question because it will demonstrate whether you've understood kind of what you're doing in the sign test or not. And it's worth 4 marks. That clearly could make a difference to you. Question 2 says calculate the sign test. Now, what I didn't mention in the previous part was that the sign test has a letter to represent the sign, and that happens to be S. Some people get really confused because the value in the critical values table is also called S, but that really should make sense to you because I'm trying to compare like with like. So I can't compare S with P because they're different letters. So the P might represent something else. So S is for the sign value of the calculated value, and the S is the sign value of the critical value. Now, actually, I don't think this should be desperately too difficult. So first things first, all I need to indicate is that S is equal to 5. Okay, so that's my calculated value. That's the value that I'm looking for. Calculate the sign value. I then need to explain how I got to that. Okay, so I need to make some kind of reference that looking at the patients, that I was able to determine that there were 12 patients who had improved, which was a plus, and 5 that hadn't improved, and that 5 is the lowest value. So please don't think that this is about like the equals sign at all, because if I have a test of difference, I can't include those 3. This is why this question is quite a good one, because of course 3 is clearly smaller than 5, but of course the 3 is irrelevant because it's the equal sign. So 2 marks in the bag. So then again, we have now 6 marks. We're not really having to do much. and that could mean a grade change. So please do kind of think that this type of work, that if you spend some time on it, will actually be an improvement. So then the final question, they give you a table, and you see it says a table of critical values. Okay, so in other words, there's only going to be one value within this particular table that works for us. Now, we have one or two-tailed, okay? So you only find 5% there and there, okay? So what we're looking at is that we need to recognize that n is 17, and so therefore technically we're looking at that value or that value. So you can see actually it poses a bit of a problem here, because we ultimately have two values that it could be, but I need to indicate to the examiner that I know exactly which value it is. So we never state the critical value table without stating everything else. So we will say it is 4, critical value S equal to 4, for n equals 17, two-tailed at 5%. Then the examiner knows that we're looking at this 4. If I don't say at one-tailed, then they think it's going to be something else. I then also need to say, is it significant or not? So the calculated value was 5. The critical value is 4. And then we see here, it says, for significance, the value of the less frequent sign is equal to or less than the value of the table. So the less frequent sign was the one which was the calculated value, and that was 5, is equal to or less than the value of the table. But the value in the table is 4. So I'm sorry, 5 is not less than 4. So therefore, it has to be insignificant. Look at the mark scheme once again. You see kind of where things are going. Okay, the critical value is 4. The calculated value is higher or exceeds the critical value. Therefore, the result is not significant at the 5% level. So I know that this can be confusing, and in many ways it just takes a bit of kind of practice. For the sign test, we need to be able to say what the calculated value is. It's always the less frequent sign. We then also need to be able to recognize that there are some participants that are not going to be included to get the n value. We then, through our hypothesis, see that it's two-tailed, and we're able to choose 5%. We put them all together and we get a table that tells us what to do. So it says for significance, the value of the less frequent sign is equal to or less than the value of the table. And if it's kind of like following a recipe. If you kind of slot the words into the right place. So less frequent sign was 5. The value in the table was 4. It says must be equal to or less than, equal to or less than. Well, no, I can't do that. That doesn't work. Okay, so therefore I have to say that it's insignificant. Now, my advice is for you to kind of read through the relevant kind of part of the textbook, go through your particular notes, and kind of try an example like this. If it doesn't make sense, obviously come speak to me, because I actually think we will get used to this. We'll get used to this idea that we're comparing a calculated value with a critical value and then making a decision. We'll get used to the fact that in a critical value table that I have to be quite precise and tell the examiner I know exactly which value is relevant to us. or else I'm not going to get the credit. So there we go. I know it's perhaps a longer video than I wanted to make, but I'm hoping that it has explained at least how I came to my answers for this and that how we do the sign test. Thank you, and I'll kind of see you soon. Okay, bye.